disconnect. It powers the entire panel, and then it goes to a distribution block inside of it and spreads it out. All the devices. The pump 1 breaker and the pump 2 breaker. Just like the main breaker, it's going to power your first drive and your second drive. These are just HMI keypads that are connected down to these soft start, not soft start, VFDs. So you don't have to open up the panel at all to be able to monitor anything. This has full local control right on it, just in case like HOAs or the PLC goes out. You can actually control the drives manually from this HMI. When you start the panel, it's going to be in remote. And that means it's going to be looking for a remote signal right here. So this way up here is currently what my PLC is currently to run at if it's told to start. So if I hit this local remote, it's going to go up here and it's going to go to local. And then it's going to tell, what do you want to run it at? 60. You can adjust speed using the up and down arrow keys. Max is 60 and its mid is at 45. So don't go above it, don't go below it. It should have run you to do it anyways. And pretty much once you're in local, you can just hit this green bar. It's going to start to pump out. Once it gets the speed it wants to, it'll stop. It's running at full hertz. You can see speed feedbacks over on the screen right here. It's running at 100% speed. And once you're done with it, you just hit the red circle. It's going to power it down. There's also a nice feature where, since I have it programmed to run at a preset speed through the jog, it's actually looking from the PLC to so fast. So if you ever have to operate it manually through this, just go to local, hit the green arrow, set your speed.
Or you can just turn that to hand.
But it has to be in local for that. And remote controls are going to go through your HOAs and the PLC. Down here we have manual PTM runtime counters, and we also have them displayed on the OITs too. We start with the indicating lights to a high level. So what will float that's inside the well level. If it reaches high level, it's going to enter backup. Backup in the normal operations, you keep normal, it's going to tell you that's normal. If you get a high level, it's simulated a high level. On high level flow activates the relay here. And it's going to switch from normal to backup. If it goes back to normal and you know everything's good, it's going to keep it in backup until you manually reset it. And then it's going to go back to 4 to 20 control from the PLC. We have an alarm silence. If there's any common alarm, we have a strobe light up here. So the strobe will flash, and then the horn will go off. You can silence the horn, and the strobe will still be going. We have a digital display for the wet well level, pretty much an output from the PLC that goes directly to it. The wet well level goes into the PLC, and we're just outputting over here, so it matches up to what's on the screen. The screen does round up to 0.1, and then this is the backup reset to reset back to normal operations. We have indicating lights for pump run statuses. It was designed. Future design is supposed to be 3 pumps, so we just included. So we got run status lights. They're actually looking into it. On the screen, it's green up here, but it's red down here. You talk with flight and minicast and everything like that. So these have minicast in here for seal and overtemp protection. If you have an overtemp alarm, it'll show up over here, and it'll also come up on the screen as a common alarm, and it tells you what is common on it. So for failed common alarm for a pump, it's overtemp, a seal leak, or a VFD fault. You have an indication for overtemp on the door, and you can manually reset them. So it's going to reset. Instead of opening the panel to reset the minicast, you can actually just press and hold. Yep. It's going to de-energize the relays, and if the alarm condition is gone, it will reset it. If it's not gone, it'll still come back on. And then there's a pump indication for faults. It is a common alarm that shows up for pump faults. So it's a consolidated fault. So it's going to tell you it's an overtemp. It's going to be VFD fault or seal leak. So to determine which common fault it is, we've got the overtemp. There'll be an FO code on the HMI, and for seal, you have to open it and check, see if it's a seal indication in here. Overtemp will shut down the pumps. The common won't shut it off. It's only if there's a fault on the drive itself, or if there's an overtemp, that's what's going to stop the pump. So inside, like I said, main breaker, it's going to feed to your distribution block that's going to get fed to your both pump breakers and the control transformer. We also have a phase monitor in here to monitor the voltage on each phase. If one of the phases cuts out, it's going to send you an alarm saying the other phase failed. So down here we have line reactors, and it's just going to improve harmonics that's going into the drives, prevent any like surges or inadequate like voltages for the drives. Just protect them. And then down here we have our CFW 500 series general purpose OEM drives. They are rated, I think, for 10 horsepower. These are 7.5 horsepower, so you have some room in case they have to like increase the pumps or anything like that in the future. And they're rated for up to 14 amps heavy duty. So that's like continual run. So it's pretty good drives. They have modules, so they're hot swappable modules. So it comes with the standard I/O, and there was some Ethernet communication. So we actually got this Ethernet adapter. It has its general inputs for like run statuses, or you tell it to run, tell it to stop. It's going to output like a fault or like a run status, and then it has Ethernet communication. So on Ethernet, we are communicating the fault back to the PLC, but there's additional, I think you can add up to like 6 additional signals you can get off of Ethernet. When you replace that module, it kind of limits how much I/O you can get from it, but you're able to communicate Ethernet. If you ever need additional signals, like say, what's the amperage? I want to see what type of amperage it's running at, or like hertz, stuff like that. You can tell it through PLC programming, like additional signals in front of it. It also shows it right on HMI, but if you want to see it, just go to this. I think it can be sent over through Ethernet. This is backup UPS. If there's ever a control panel power fail, it will run to UPS backup power, and it will run it PLC. It's pretty much, I think, estimated runtime is about 25 to 30 minutes, but it's pretty much just going to be used for alarming. If you do have a power fail, it means you've lost your main breaker, so you're not really going to be able to operate any pumps anyways. It'll just allow the PLC to send out every alarm it has pretty much over to SCADA, and it'll warn you, say, hey, you have a power fail. That's coming from this BMR relay. Now, so this side, we'll work our way over to here. So we have an 8-port Ethernet switch, which is using communications between Ethernet equipment inside and communicating over to this panel over here for back to SCADA. We have a temperature switch, which controls the spoke fan. So pretty much if this panel gets over 95 degrees internally, it'll kick on the fan, and it's going to suck all the hot air out, and it's going to, it has its vent on this side, so it's going to pretty much circulate through and out, and it's going to cool down the internal temperature of the panel. Over here we have our compact logic 5380 series PLCs. It's the whole brains of the operation. It's what controls all operations and all alarming. So this is the CPU. These are the input modules. This is the output module. These are your analog modules. You want to see lights up here, it means the module's powered up. It has mod power and SA power. So if you ever see any of those lights out, it's pretty big concern because there's some sort of power issue that's going on inside the controller. So that's something to monitor. There is a signal, PLC fail. If the PLC does fail, should be able to get that alarm to SCADA. Second row down, we have our control power coming in. And it's protected by, we have a circuit breaker and a surge suppressant device. If there's ever surge inside the panel, this will trip. It's green, and if you ever see it like orange little tab in here, that means there was a surge, and you'd also get an alarm on the HMI.
How do you reset that?
They're hot swappable, so if there's a power surge, you have to replace it. Part number right down there, and this is just Phoenix contact. So this leads us to some of the relays that are taking in signals from like the wet well and the power. So the first one's your power fail relay. Like I was talking about with the UPS. If you lose control power, this is going to swap over, and UPS is going to take on control voltage for a little while, and it's going to alert you. Ringing alarms. These are just alarm circuits. So we have our alarm relay and our silence relay. If there's any alarm, it's going to activate your alarm relay, and then you can use the silence relay to silence the horn. LSHH, this is your high level float. So it comes in from these ISRs down here, which are used to prevent a bunch of hazard, sending voltage you don't want to a hazardous location down in the wet well. It's prevent from like explosions. And so the high level comes in, it's going to activate this. You can tell, see the indications. This means that the relay's active. So if it's active, you have a nice indicating reference. Next up to it is your level set point 1 and your level set point 2. So this is for the backup control. So say your transducer goes down and the water in the well keeps filling. It's going to hit level set point 1. And it'll keep going to level set point 2. And then it'll hit the LSHH. Once the LSHH kicks on, it's going to allow the backup circuit to start running, and it's going to start both pumps, pump down to the low level, the LSL, and the low level is going to open that circuit, and it's going to break it. So you have to manually reset it. Now, the next operation, it's not going to look for the level transducer. It's going to hit level set point 1, it's going to run it back up. If it keeps filling up, it's going to hit level set point 2, it's going to keep doing that. It's more or less so, if the transducer does fill, you don't want it filling up to the high level every single time.
Right.
And then you're starting both pumps. It acts as, it's pretty much a barrier between that, so you're not constantly running both pumps in backup. There's the LSLL, which is the low level. That just sends you an alarm saying that very low level shit when it comes off, and it locks it out. Next to that is our CHR, which is used control relay high, so that's what energizes the backup. LSHH will actually activate CRH, and CRH is what gets latched in. This is what gets reset, backup control. And so then we have our control fuses, distributes power throughout all the devices in the panel. If a fuse ever gets blown, there's actually an indication in here, so it would glow red. You'll be able to see it, that if there's a blown fuse, it'll glow red. To replace it, you just throw it out like that. There's a flip out door on the side, pull that down, and the fuse is right in there. To know what the fuses are, there's contract drawings. You pretty much look through the pages, find your F number, the F17, and you pretty much just right on the page is going to tell you what the amperage that was there before. So right down here we have more control relays. This is more or less for relay logic inside the control panel, and your digital outputs all coming from this relay up there. So the ones that have this orange, that's all 120. It has blue, that's 24 volt relays. Just like your surge device, you can replace the relays, you can pull them out, and you can check the part numbers and everything like that if there's ever an issue with one.
Is there a button I can press to trigger it?
You just pull down on it, and it's going to activate. It doesn't show you the indication when you pull down on it. It just changes your contacts inside of it. And so if you ever need to test something.
What's the teal?
This is the 24 volt, and wire codes, the red's 120, white's the neutral for 120, the white is the blue stripe, the PS minus. Yellow means it's unknown voltage coming from a foreign source. The green with the yellow stripe is ground. And then we have twisted shield of pair for analog signals. These are just terminals that are used to power the HMIs. It's just 24 volt that goes over, and then there's the mid-cast for sealing over tap protection. They have the auto manual reset, push buttons on them. Right down here is our power block for the UPS. And this is what gives it the power to it, and then this return comes back into this power block, and then it gets distributed throughout the panel for using UPS power for the 120. There's just some spare terminals for both 120 voltage and 24 volt. This is coming off of PS power supply 2. We have 3 power supplies. So these are 5 amp power supplies. You feed them with 120, they output 24 volt. In the future, if you ever need, if you have like issues with power supplies, they actually have built-in contacts. So you can monitor if one of the power supplies goes bad. It'll use the contact, and it could be used to display any issues out to like SCADA. These are just field wiring terminal blocks. So this is just power equipment outside the panel. This is TB1. So the TBD1 is your digital inputs. So most of these are spare, but a few of them are for a future pump 3. We gave you terminal blocks, so it's just quick and easy. You can just wire right to the terminal blocks for anything you need to monitor, exactly like these ones. And then we provided you 25% spares on all digital and analog terminal blocks. So TBD2 is your digital outputs, the yellow wiring, because it's going to be a foreign voltage that comes into it. So what we do is we output to a relay, and then on the dry contact of the relay is what gets alarmed out on the digital outputs. Down here is your TBA1, which is your analog inputs. First channel, this is your level. So this is a surge suppression device. Just since it's out in the well, if there's any like a lightning strike or anything like that, the surge protection device is going to prevent anything from going up to your controller. And then this is just spare TBA2 terminal blocks, which is your analog outputs. Down here is your intrinsically safe relays area. It's a 5-float system. So you have your low, which is just an alarm. Then you have your low level, which is used to shut off your backup. You have your level set point 1, and level set point 2, so that's going to start your first pump. You reach level set point 2, so you take your second pump. Then you have your
pump will start at the high level alarm, and then your high.
So that's the 5-float, and then this one's just intrinsically safe barrier for the 4 to 20 signal.
Yep.
So you have your well, and you have your 2 pumps, and you just get your well level, and this delay will actually go up with the level of the well. So the transducer we provided is ranged from 0 to 10 foot, and it was mounted with there's a 9-inch offset. So we have it scaled from 0.8 to 10.8 feet. So you want to keep it within that window when you're changing set points, like level control.
Transducer, is it a foot off the bottom?
And then it was 9 inches off. There's login security. People like change set points, you gotta log in.